lecture on 5G and beyond technologies. So in this course, as we said, we are going to understand and explore 5G technologies and the beyond 5G technologies, not only 5G. Basically, we'll understand the use cases, the applications that 5G is trying to serve and cover and satisfies, understand these requirements, and then understand the technologies that are anticipated to meet these requirements. Then there will be some open challenges with new requirements. These new challenges and new requirements will try to come up and design new techniques, new methodologies, and new applications that can satisfy the requirements of beyond 5G, not only 5G, 6G, 7G, and this and that. So what's the driving factor for standardizing new generation? The driving factor is the huge increasing demand year after year on mobile data, the emergence of new applications. For example, the number of mobile subscribers in 2010 was around barely 5 billion users. In 2020, we are here, almost everybody on earth has a mobile phone, almost. It's like around 8 billion, and the population of the world, 9 billion. Means this is becoming indispensable part of your life. You cannot live without your mobile phone. If I take it from you, you are lost. You cannot organize your life. You feel depressed. It's becoming part of our life. There are good points, there are bad points. Some people, the socialists, they say it's dangerous to keep tuned to your phone and using it. Any technology in the world has two edges, bad and good. So we try our best to use it for the good things and try to make it a servant for us, not treat it as master and we are the servant. Technology is created to serve you, not to be servant for it. So this is very critical. Help you convey your ideas, help you to help others. Exploit it in good ways, not in bad manners. And these are the things that are related to ethical and societal kind of requirements that everybody must be aware when he's dealing with technology. The data traffic, what about the data traffic? As you can see, internet is becoming popular, everybody has access to the internet, and the speeds of the internet is increasing year by year. And most of the data traffic, as you can see, in 2013, USA was almost #1 in the amount of data consumed. And then after that, Asia, which includes China, India, and this, although the population, Pakistan, India, China, the number of people is larger than USA, but the amount of data consumed by USA is more than this, more than the amount of data consumed by China, India, Pakistan, and the countries in the region. Why? Because the internet was not dominant there. Just in the cities, maybe, not the villages, not all the people are trusting it or saving it. Because the technology was born in USA, the internet technology. Who was using it first? The scientists. The internet, the idea of the internet was used to communicate scientific documents between 3 universities in USA. And they found it, why don't everybody use it? Imagine, it was they were using it, the government and universities and scientists, for many years, and they didn't disclose it to publics. So then they said, why everybody can use it? We don't know what kind of application people will use it, but everybody can use it. The main purpose, the motivation of creating the internet is to share the scientific information, basically the publication, with scientists in different geographical areas. And then in 2014, as you can see, the overall data traffic is increasing, monthly IP traffic is increasing, and as we can see also the other countries, all of them increasing somehow in a scalable manner. Relatively, they are increasing with fixed percentage almost. But in we are in 2020. Even the diagram is more than this. The amount of data traffic and the amount of data generated is expected to be counted from now on by exabyte, 10 to minus 18. Not tera, 10 to minus 12, not beta, 10 to minus 15, 10 to minus 18. So mobile internet traffic growth is pushing the capacity limits of wireless networks. More demand, more application, I need more speed, I need faster internet, because I have many applications on my phone and all of them are hungry for more speed. What's the solution? The solution comes from you as engineers to come up with technology that can meet this demand. For example, going back and to the current, from 1G to 5G, the evolution of generation, there are three things that characterize any generation. Basically, we have, in general, each 10 years, we have a new generation for wireless systems. In first generation, it was around 1980s, and the amazing service that was offered to people is to be able to talk to others wirelessly, not with wires. That was fabulous, amazing, astonishing. It's like magic at that time. Talk wirelessly with people. Although the phone was bulky, large, and the technology was very basic, frequency division multiplexing, and the design is so analog. The design is analog. But it was amazing that you can communicate wirelessly, not without a cable. Who imagined that? At that time was astonishing. After 10 years, 90s, we moved from 1G to 2G. And the amazing service that 2G was able to provide is SMS texting, email. It was not available before. Not available. You cannot send message. If you want to send message, you must write it and send it by the post. There is no such thing you can send message, SMS, ask your father, or email, or this. At that time, it was astonishing. I mean, you killed the career of the people who are working in message post, and they are dead. But like such an amazing service, SMS and email was amazing in 1990. And the mobile phone becomes a little bit smaller, and the technology was TDM, digital, time division multiplexing with a frequency division. So three things changes: the application, the technology, the device. In 3G, what was the killing application? For the first time ever, you are getting internet wirelessly. Internet. And this opened the way to start creating applications for your mobile phone. Previously, in the old phones, did you have any applications using the internet? Just SMS, the contact number, the phone, nothing, yes? Empty. You just go back and check your mobile phone. And that was revolution. What was the technology? CDMA, code division multiplexing. And the font changes. They tried to increase the screen because now you have some kind of application and you want to see them. And for the first time, actually, in 3G, you had camera with the phone. Yes, camera and sending it. It was magic. Magic, I remember in 2005. In 2005, when you saw a person who has phone with camera, was really, really something wow. And in 4G, we even get rid of the keyboard. Yes, totally. Your phone is whole screen and everything is embedded behind. So the device changed, and the technology was OFDM. The technology changed. Why the technology changed? From CDM to OFDM. The ones who talk wireless, they know. The speed of the internet. You have many good applications, from all of them require high data rates. But what's the problem with CDMA? The problem with CDMA, when you increase the data rate, the symbol duration shrinks. When the symbol duration shrinks, with respect to the multipath, the delay spread becomes very small. So delay spread duration divided by the symbol duration becomes large. Let's say 10 taps. 10 taps at the receiver, what does the receiver need to do? Needs to equalize. When the receiver goes to for equalization process, extremely complex in time domain, exhaustive process and complexity, the battery will run out quickly and will not suffice you to use it for longer period of time. Because all the applications they require high speed, high data rate, and because of this time domain equalization is killing your battery, and it's not. So what's the solution? Until they came up with the OFDM, they said OFDM, no matter, you can increase the data rate as much as you can. We are not going to perform equalization in the time domain. We are going to add CB, cyclic prefix, at the transmitter. And when you send your signal, it convolves with the channel. And at the receiver, we remove that CB and do the equalization once, one multiplication process in the frequency domain. That was the groundbreaking technology. Although OFDM was invented in 70s, but nobody was able to implement it. I-50 was very difficult to implement it because of FPGA and electronics were not developed at 70s. But in 2010, the electronics becomes really, stronger and available in the market with small sizes and different technologies competing with each other. So they were able to design the I-50 process at the transmitter and receiver, and this enabled 4G. With 4G, we got the iPhone, we got the Samsung phones, we got the full screen phones. So where are we heading in for 5G? Yes?
What do you expect now?
5G, well, where are we? Yes? Of course, we are still hungry for high data rates. We are not happy with YouTube and the speed of the internet and the download and the speed of the websites. We need faster. We need, when we click, it just automatically. So 5G promises that a 3 gigabyte video, you can download it in seconds. That's astonishing. In 4G, you cannot do that. So the speed of the internet, instead of 1 giga, it's going to be 10 to 20. 10 to 20 giga per second means a movie of 1, 2, 3 till 10, you can download it within seconds. That's something we cannot believe. Yes, China, USA are going to be the first to be using these things, Korea maybe, Japan, but it takes time until it becomes widespread. Not only this, there is a new type of application emerging in 5G. What's that? Internet of Things. Now, the internet is not going to be only the internet of people. It's not going, we used to design our services to meet your requirements, but now we have the objects, they also have some requirements, and we want to meet their requirements. The Internet of Things is a technology that's going to connect almost every object with the network to communicate, send data, execute data, analyze data. So it's going, when you give the object the sensing capability, seeing, hearing by sensors, recorder, camera, and the communication capability connects with the internet via wireless interface, Wi-Fi or 5G or whatever that interface. And actuating capability, microcontroller, where it reaches when something happens in this pin, take action in that pin and make things happen. Then it becomes like a human, robots, yes? Chip connected with what? With an object. The chip acts like the brain of that object. So the student, in many classes, I see students developing Internet of Things application. One chip has microcontroller, wireless interface, and sensing, actuating capabilities. And you connect with this chip any sensors, and based on the application, you customize it and you make anything smart. You start saying smart table, smart coffee making, smart kitchen, smart home, smart city, smart TV, smart transportation. Why? You gave it the sensing capability of human being and the capability to communicate and talk and this. So it's such an unbelievable phenomenon is going on, the Internet of Things. So 5G, in terms of applications, it's going to be revolutionary. But in terms of technology, the technology, surprisingly, for the first time ever in the generation, almost similar to OFDM. They tried to invent a new modulation scheme. We will explain them in next lecture. Many modulation schemes, many innovations, people from all over the world. The researchers, the scientists, the company competing with each other, trying to come up with a new modulation scheme. And after all these efforts, all the money they have spent to come up with a new technique, they settled down to OFDM with some variations. We call them numerologies. So basically, the devices are not clear yet. What will they be? So we know the technology because it's already standardized, variations of OFDM. We know the applications which are mission-critical control, massive Internet of Things, and enhanced mobile broadband. The characteristics or requirements of these application that features them are given below. Mission-critical control, you have to provide them with strong security, ultra-high reliability, and low latency, like controlling a drone, remote surgery operation, factory automation, driverless cars, autonomous cars. All these applications, without 5G, you cannot make them a reality. You need extremely low latency. Wi-Fi, horrible in latency. If you delay informing the car to stop at, for example, 0.5 second, and it stops instead of 0.5, 0.9, you make an accident. How can you design such a technology that it avoids such a delay? It's very critical. Driverless cars and autonomous cars and all these things require extremely low latency. Remote surgery operation, surgical operations. If the doctor touched something here, he's in Turkey, and the other patient in USA, must extremely autonomously and exactly simultaneously act in USA. Whatever you do here, it performs there within millisecond. The latency in 5G less than 1 millisecond, no more. In the previous generation was more than 10, 50 days, unacceptable. So the new thing in 5G, we don't only need high data rates, as we used to say in the previous generations. We need low latency communication. We need extremely reliable communication with low complexity. Internet of Things devices, do you think that they can bear the complexity of too much processing and this and that? No. Internet of Things devices, they are limited in memory, in processing, CPU, in storage, in battery, limited in all the precious resources. So what's the solution? The solution is to come up with technologies that can make things simple, less complex, but also reliable and meet the requirements. This is very challenging. Two things opposite to each other, you are trying to combine them, which is tough and hard. That's why encryption, one of the things that they are stuck at encryption, as we mentioned before. Encryption is, the more you make things complex, the more secure your system will be. But when you make things complex, you will drain the battery, you will drain the CPU, you will run out of resources quickly. Yes or no? So conflicting with each other. You want it secure, you want it high reliable, low latency, but also low complexity. How come you can do that? So we have projects right now running with my students on how to tackle this problem, you understand why we are trying to come up with technologies, new technologies that can handle this problem. Low complexity schemes, but can achieve low latency, power efficiency, high data rate, and not too much cryptographic complexity. That's very challenging. Any technique in this domain is very welcomed in the 5G and beyond technologies. 5G now already standardized, but still not being deployed in many countries. So this is for mission-critical control. For massive Internet of Things, you need deep coverage. You have billions of devices communicating with your network. You need ultra-low energy. You don't want the Internet of Things device to consume too much energy to reach you. And you need to be able to serve users devices when you have limited resources. You have 100 slots that can serve 100 devices, but the number of devices the number of devices that want to connect with your network is 1,000. You have only 100 resources, can serve only 100. How can I serve the 1,000? Isn't it a challenging problem? So to do that, what do they try to come up with? New techniques, new methods. Example on these, non-orthogonal multiple access scheme. Same time, same frequency, same slot, put them on top of each other in the power domain, and let the receiver separate them, which is clever way of doing that. Not only mission-critical control and massive Internet of Things, but also we want enhanced mobile broadband. In this case, we want a new bunch of requirements. One, extreme capacity in terabit per second, extreme data rates, and support high mobility when you are moving with a train, with a plane. The plane has to be served with 5G and 6G in the future. The passengers in the plane are being covered by internet connection with a speed of 10 gigabit per second. Imagine this. Many people are traveling by planes these days. Many airports are being opened day after day. Billions of people are traveling. There are people who are spending like 1/4 of their month on the air. Keep traveling, going, and this. So there is a demand that I need to see my messages. I need to see my videos. I need to communicate. You understand? Not only for entertainment, like you see right now in some airlines. They have server for videos and they make you think they have the internet, but it's not the internet actually. It's you are getting the videos stored on the server of the plane. Yeah. And they distribute it to you. You think it's the internet. It's not, basically. It's just for entertainment purposes. So there is a huge demand for users. The life is changing. The world we are living in is not exactly the same world we were. Your father and my father, my grandfather used to live. Things are becoming extremely complex and demanding. So we have all these requirements, and the common things in these requirements is data rate and speed and high throughput and this and that. So what's the first thing we can think about and say that it might be capable to meet these requirements is the spectrum. As I just mentioned before, when you go up in the frequency, you have more bandwidth. More bandwidth from Shannon capacity equation, you can deliver faster internet, high data rates. And RF spectrum is basically the starting point. When you want to increase your data rate, the first thing you think about is the spectrum. when a company wants to expand and serve more users, the first thing comes to their mind, okay, buy new spectrum from the government, buy new spectrum from the government. But what happens to the spectrum? Finishes. The spectrum for mobile, for wireless mobile company, there is no more spectrum in the golden region, which is from 400 mega to 3.6 giga. Why we call this golden frequencies? Because they propagate through the walls, through the trees, and they can reach 50 kilometers and still provide you with service. That's why we call them gold, very expensive frequency. 1 mega, $1 billion. 1 mega, you take it, you buy it from the government, $1 billion. They finished. What can you do? More applications, more customers, more demands on videos. If you were offered to learn something by video and learn it by text, which one would you choose? Video. Everybody would choose video. But video is costly to the network. Tough. I mean, not like you don't imagine the data center of YouTube. YouTube is like a city. These servers. Imagine like this computer has hard disk. Let's say SSD. What's the capacity of it? Let's say 200 giga. 200 giga. Each video on YouTube is at least, there are, let's say on average 1 giga. How many videos you have on YouTube? Do you imagine the size of the data center? And do you imagine you need this, not only the storage, you need also cables that can transfer this quickly. You need higher speed. So all these are limiting factors and challenges. Basically, to solve the bandwidth issue, one of the things to go with is the spectrum, increase the spectrum. But as I told you, for wireless, when you increase the spectrum and go to giga, the signal frequency becomes large, lambda becomes small, so it cannot penetrate through walls. If it cannot penetrate through walls, the range of your communication becomes limited to line of sight, which is not desirable. So you gain something, you lose the other. As you can see, all of them contradicting with each other, very challenging. How can you put them together? That's the answer the scientists are trying to solve. RF spectrum is a national resource that's typically considered as exclusive property of the state. Who's the owner of the spectrum on the air? The state, the government. So a company wants to expand its operation, wants to serve more users, you need to buy spectrum from the state. And whatever the state says the price, you have to accept it. If you don't buy. There are others who buy. RF spectrum usage is regulated and optimized by the state. RF spectrum is allocated in different bands and is typically used for radio and TV broadcasting, government, defense, industry, public safety, commercial services, voice and data. These are the where you use the RF spectrum. But if you look at here and see the RF spectrum investigated with me, we usually divide it into 5-6 regions. To the RF band, we call it microwave frequencies, that covers from 3 kilohertz to 300 gigahertz. And this consists of high frequency, very high frequency, ultra high frequency, super high frequency, and extremely high frequency. This is below the IR, below the infrared. Our communication systems these days are using only till here, around between this region and this. Basically around here, this point. Gigahertz, when you say 2 point. The infrared is not yet utilized for communication. The visible light communication here, they started already utilizing it for communication. What we call it Li-Fi, not Wi-Fi, Li-Fi, light fidelity. Li-Fi is using the frequency in this range, and it's basically using the light to carry data. So it's limited to indoor. And you have also X-rays. After visible light, you have ultraviolet, which is basically the laser that we were explaining in exabyte, in peta, the frequency, 10 to minus 15 here you have, yes? 10 to minus 15 is laser. When you reach here is laser. And you have the X-rays that they use in medicine. It just short distances. It can give an image of your inside body. And you have gamma ray, which is extremely dangerous. And if it touches anybody, because of the high energy that it has. So basically, we are here. We are basically trying to utilize this for communication. Ultraviolet is used, laser used for optical fibers sometimes. So as you can see in spectrum, we are limited. So no matter what you go, and especially when you go up in the frequencies, you cannot use them for non-line of sight wireless communication, the way we use them in our phones. I want my signal to be received, although I don't have line of sight with the base station. So it's challenging. So what's the other solution? If spectrum is not enough, to go for network densification, increase the number of cells. Instead of putting one cell in a region, put 5 cells, 10 cells to serve more users. But what's the cost of this? It's costly. You need to rent places from people and buy new equipments and new devices. So it's costly and not recommended. So the only solution we are left with is the spectral efficiency. But what's the problem with the spectral efficiency? It requires clever minds to increase it. Techniques, novel algorithms, signal processing. Yes? So here, money, the problem with these things, money and propagation and cost and power, and here rent and other things. So these obvious solutions are very expensive and not desirable. We rather prefer to improve our intelligence and come up with new techniques that can improve the spectral efficiency. If we improve this, then the overall traffic capacity, area traffic capacity will improve. What's the area traffic capacity by definition? It's the number of bits you can serve per second within square meter. This meter, how many data rate you can serve? How do you calculate it? You multiply spectral efficiency by network density by spectrum. So the spectrum efficiency, let's say you are using 16 QAM, 4 bits per second per hertz, per node, per device. You multiply it by how many nodes within 1 meter. Let's say you have 10 devices. 10 multiplied by 4, you have 40. And suppose the spectrum, the amount of bandwidth you have is 5 mega, 40 multiplied by 5, 200 mega, 0.2 giga. This 1 meter square, 0.2 mega, 0.2 giga. 0.2 giga is, can be consumed by one video. You understand the limitation? You understand how we calculate it? So we still need novel innovative engineers who can produce novel techniques to meet up, to cope up with this demand. You understand the need of this course, the need of where is the technology heading, where are we, and what are the requirements? It's very, very crucial to understand the importance of this. Any new idea you come up with nowadays, we'll do this. Any new idea you come up with in this domain, and we investigated and discussed it and agree that it's novel and this, we go to the blockchain. We patent it with the blockchain technology, not expensive. And then you try to market it to the companies. Email the companies who are working in this field, recently this technique is developed and it's meeting the requirements of this application. So if you are interested in buying it, we can license it to you. So you have an opportunity to become a multi-millionaire student before finishing your master if you put your heart here, your mind and your heart. A multi-millionaire student. If you can come up, of course, we help you, we guide you, but not only come up with a technique, email the companies that are interested. Email it from a strong point. You are not employee, you don't want them to hire you. You don't want to work with them. You are partner. You are innovator. You are developer who came up with a novel technique and you want to license it. Even not sell it, license it. Renewal barrier. From a strong point, you have something. And nobody can steal it from you because you already patented and secure it. And you don't give all the detailed information so that if they try to do it by themselves, there is some missing until they ask you and tell you. If you put your heart here and you know how the game is going and working and invent a novel technique that we investigate among ourselves and we say it's novel and it's viable, we will patent it for you. And you start emailing the companies who are interested, and many companies will welcome that. Because if you solve a critical problems, challenging one like the previous ones we mentioned, I mean, money is nothing when you can solve such a problem. Because the problem is beyond the value you are providing. The value you are providing is more than whatever the license cost will be. You understand me? But the problem, you need to be tough with yourself and serious and committed. Not going here to hang out, just get a degree and start running after companies. Please, please, please hire me. Oh, no, you are not good enough. You are good, you are intelligent, you are innovative, you have all the capabilities. Why you prefer always to come from the weak point? Why don't you talk from the strong perspective? You have an opportunity here. We are teaching you state of the art, things that are not teachable anywhere. Not teach you, memorize, take exam and go home and this. Teach you to the level where you can contribute, add new things to this industry. If what you do is valuable, we can also help you patent it, and then your responsibility to market it. Because no matter what hard work you put in your technique, if people don't know about it, it's as if you didn't do anything. That's why we publish. That's why we upload our documents and share it and we try to make it in the perfect level possible. In the most perfect level possible so that people can see it, look at it, if they are interested, collaborate, and there are the governments who are giving projects. If they see you producing novel things and this, yes, if you apply to a project, they will think of giving you, trusting you on their money to build new ideas and new. But if you are not showing them anything, I'm saying this just to show you the importance of marketing. Marketing, not low quality work, of course. Let people laugh at you. Try to market something valuable. You put your heart in it. You sweat doing great things, and you try to make it in the best manner possible and to deliver it to the community. And once you do that and people believe in that, then you can ask whatever you want because you are on the side of power. So these are the things that I want you to take really seriously during this course. I'm not, again, tell me this, I'm not taking this course just for the grade. Grade are trivial, not our goal, shouldn't be our goal. Yes, we agree on that. Our goal is to seek high quality innovation and high quality work that can impact the world and do something great that can help you, help your family, help your country, and also try to get your freedom, whether it's financial or time or being the boss of yourself, or whatever you call it. There are many types of freedom. When you do one invention, it can somehow liberates you. Yes? It's up to you. You decide. You work hard for a few months, few years, and then you rest for the rest of your life, or you rather prefer to keep doing low quality work and work hard for the rest of your life. You decide. So that's something to consider very seriously. So now we understood the area traffic capacity, how to increase it. For increasing the spectrum, we use carrier aggregation, millimeter wave frequency, terahertz, laser, optical wireless communication. This solution is to increase this parameter here, the hertz, the bandwidth. For increasing the node density, we use cell densification, we use spectrum sharing, we use cloud radio access network, we use small cells and device-to-device communication. For increasing the spectral efficiency, here your mind. I want your mind to be here, because these, if you go here, little innovation, I mean, you just go up in the frequency and you try to make things work there. Yes? And maybe sometimes because of limitation in terms of budget, you don't have hardware devices, you don't have too much funding to start such a project, you are most likely deprived from this. You cannot do much here. So here, for this, spectrum sharing, device-to-device, small cell, you still have something to do here, but the problem these solutions usually are costly, requires renting new sites, new components, new devices, and not somehow close to this solution. Not much intelligence. The intelligence is mainly in the spectral efficiency, trying to increase the spectral efficiency with novel signal processing techniques, with novel methods and ways, schemes, designs. For example, massive MIMO is one of the techniques, full duplex radio, interference management, interference alignment, interference mitigation, artificial signals, artificial spaces. These are some of the techniques. But what I want to see by the end of the semester, I want to see another solution by one of the students here, or two or three, another solution that can improve this formula. Yes, the red one, red. For example, new solution here, a new name for your solution that can improve the red. Here there are students who did this. We are working with students who did this even when they were undergrad. So it's not difficult once you synchronize yourself with your advisor, with your teacher, and tell him, I want to do great, impactful work on the world. I want to teach me quickly the state of the art, what the world in need of what, I mean, and what are the techniques that can start from, what I need to do, and you have goal. Whatever it takes, I do. I need to learn Python, learn Java, learn scripting, learn MATLAB, whatever it takes. As long as I have the goal, I keep going, moving forward. Just go Google quickly. Few hours, you learn that thing and go back. Learn that things and go back. When you have goal, you are always motivated. Because if you learn something, if you stuck somewhere and you want it, you need it, you know why you are learning it. To achieve your goal. So you don't even consider it hard work, or you are enjoying it. But when you don't have goals and you work hard and learn things, but you don't use them, it becomes boring, tedious, not exciting, not anymore motivating you. Yes, that's why very important to set goals. Where do you want to go? Where do I want to reach? What I want to achieve? Once you put that goal, you start building all the learnings, all the things. You don't consider them work because you are motivated. You have a reason why are you doing this. But when you take all the classes and here and here and here, and you don't use it, at first you suffer from lack of motivation and lack of focus. If you don't focus, you don't do well. Because we are, I mean, with the knowledge we have today, you cannot say, I want to learn everything, I want to know everything. If you try to do so, you will not know anything. So try to focus. I want to be in this domain. Stand out. I want to solve this problem. Nobody solved it. I'm gonna solve it for the first time in the history of the world. Don't say impossible because other people didn't achieve it. Nothing impossible until someone comes and does it. It becomes possible. Then everybody will be able to do it. Yes? So that's even in running, in sport. The 5 miles, the 4 miles by few seconds, or the first guy who broke that record, then after he broke that record, hundreds of people started breaking that record. Why? Because in their mind, there is a guy who achieved that. Then if he achieved it, I can achieve it. But what if nobody has achieved it? I cannot achieve it? No, because you are believing in that. It's a matter of belief. If you believe in it, you will do it. But if you say, they didn't do it, how can I do it? It's a matter of belief. You restrict yourself. You limit it. But there is no limit. The potential is infinite. So, spectral efficiency improvements, as we can see, these are the factors that are mapping to different spectral efficiency schemes, and as we can see from the figure here, spectral efficiency gains are slowing. Why? Because people are not anymore smart like they used to be in the past. Our grandfathers, the people who were in 80s, 90s, they were smarter than us. See, the curve here was linear. We are here, it's saturating. This means the people here were smarter than us. They were able to come up with technique that can increasing the spectral efficiency amazingly. So what's wrong with us here? We don't work hard. We are distracted with Facebook, Instagram, Twitter, YouTube. Something happened here. Why? In the old days, there were no Facebook, no Instagram, no Twitter. People are focused. Today, every once in a while, a message comes. Someone ringing, go out, chat, this, that. Really, you are losing your focus. Distraction is the enemy of production. The enemy. Distraction, being not able to focus, work continuously for a long period of time on something is one of the enemy preventing you from achieving great things. I heard in USA, in University of South Florida, one of the universities, in 2005 or 6, the students were prevented from using their phones, and they didn't have applications like this, just the voice and the messages. They were not allowed to use their phones. They come to the office, the PhD students or not. They put their phones, they take them in the evening at 12 or 1 a.m. They come at 8, they remain in the lab till 1 a.m. They take their phones and go home. Yeah, of course, innovation, if you want to innovate something to impact the world, do you think it comes with ease? No pain, no gain. If you want to do something great, you must focus, put your heart in it, isolate yourself totally. No social life for 1 year. No Facebook, no Instagram, no Twitter. No, understand me? It takes courage to do that. Not everybody can do it. And they will say you are antisocial, you are extrovert, you are introvert, you are you. They will say these things, of course, because trade-off, life is trade-off. You choose this, you lose there. You choose there, you lose here. So you determine what you want. The most important thing to determine what you want. So here, these are the assignment of the frequencies in the RF to different applications. All these applications that we have used up until these days can fit within this spectrum. This amount of spectrum. And the ones responsible for increasing the bandwidth are, as we said, the carrier aggregation, millimeter wave, terahertz, optical. They are colored in green. Usually, the people who work here are the ones who have fundings, big fundings from companies to buy devices, expensive devices, because when you go up in the frequencies, the devices becomes extremely expensive. In my, I know labs that they have devices, one device, $5 million. One device just to generate signal or receive signal at gigahertz. Very expensive. So normal people who are getting started it's very difficult to work on this area. So the poor people, like all of us, we are poor, who don't have too much fundings and millions of dollars, we prefer to work in the spectral efficiency domain. We prefer, since we don't have the money, we try to compensate it by putting intelligence. Yes, but there are fields that require both money and intelligence. Yes, you must be rich, and smart. If you lack any of, you are out. So there are domains like this. So hopefully you will, now with your intelligence, you will achieve richness, and then you can move to the areas where you need to be rich and smart. That's the strategy. Okay, so 5G vision support a broad range of devices and services, including telepresence, massive connectivity, Internet of Things, everything on the cloud. As I said, in the future, you may not need this phone in your hand anymore. Like maybe a ring or necklace or anything, wristband or whatever, and everything will be on the air. The screen on the air, your storage, your cloud on the cloud, your storage, your processing, everything on the cloud. The internet is so fast, the latency is so low that you don't need to have any storage or memory or processing on your computer. You can get it from your server that's hosted in somewhere, I don't know where, and it reaches you in milliseconds. And the screen, you don't need a screen because the air is the screen. You just, with one click on your ring or whatever, the screen, and you move up and left and down like the idea you were talking. It's very possible when we have technologies that can enable low latency, high speeds, and everything can be put in the cloud. When everything can be put in the cloud, you don't have any more, you don't need memory, you don't need RAM, you don't need on your PC. Everything on the cloud. And it's fast, the internet fast, so that you don't need to wait long. So this is the vision of the future in communication system. Efficient support for various usage scenarios such as enhanced mobile broadband, massive machine type communication, ultra reliable low latency, introduction of new radio access technology to utilize various spectrum bands up to 100 gigahertz. Right now in 5G up to 100 gigahertz. So basically the services that 5G trying to cover and meet their requirements, ultra reliable low latency, as the name implies, reliable and low latency, massive machine type communication, Internet of Things devices, enhanced mobile broadband. And these are the requirements of each one of them. We already explained them before. Here, ultra reliable low latency, 1 millimeter wave area frequency, 5 millisecond end-to-end latency. The mobility 500 kilometer per hour. This is train speed. This is airplane speed. Yes, 500 kilometer per hour. It's not a car speed. There is not any car can reach this speed. Largest speed as 300. 300 maybe. Largest speed for cars 300. So when you go here to this speed, I think it's airplane. So this means that the target is to cover the airplanes as well in the future. While you are flying, the problem here Doppler. That's the critical problem. OFDM fails when there is large Doppler. So maybe new techniques, new methods, something. Anyway, this is to give you example to think why they are targeting 500 and more. Massive machine type communication. You have million devices per kilometer, large coverage to support devices in harsh environments like in factory. Extremely long life battery for low cost devices. And also for enhanced mobile broadband, you have 20 gigabit per second peak data rate, 100 megabit per second user experience data rate in general as an average, spectrum efficiency by 3 times over the previous generation, and the mobility is 500 kilometer per hour, and network energy saving 100 times more than the previous generations. Is very, very ambitious requirements. So if you were to summarize 5G, it's basically scalable modular design, easy on-demand integration of modules, can integrate with the current technology, support a broad range of services, enhance mobile broadband, massive machine type communication, ultra-reliable low latency, and its service-aware access, configurable resource according to service demand, flexible use of network radio resources, and forward compatibility. Don't care about the backward compatibility. Forward compatibility, allow easy extension of future services, flexible design for future spectrum assignments. So basically, the requirements are very, very, tough to meet, not easy. And we need smart brains to come up with solutions that can meet all these contradicting requirements. But at the end of the day, the ones who dedicate their time and energy and resources to come up with technologies that can meet these requirements and quickly transfer these requirements, these technologies to business models, they are going to win the market. That's why we see the battle between China and USA over 5G and who's gonna make it first, who's gonna serve the countries, and who's gonna make it first. And even Trump and others, they said to the companies, why the companies in USA are lagging behind. We want 5G to be ready as soon as possible, and even 6G. And we are not going to allow, for example, Huawei and others to work in our country. And it's really tough because technology nowadays is power. Whoever controls the technology and takes it first maintains its position. And whoever doesn't take it seriously will be left behind. And in the 20th century, the power was the airplanes and in wars and this. In the 21st century, the power is technology, basically the networks, the wireless, the computer, the communication. These are the weapons of this century we are living in. So basically, try to learn it, understand it, and use it for the goodness of the people all over the world, without any discrimination, without any hatred or, bias. Just you are a human being. You try to do good things, good deeds, good works that can help everybody, regardless of his race, of his country, of his, anything like they used to discriminate people. So this should be the goal, and we try always to do great things as much as we can. Yes?
So before 2 or 3 slides, there was something about prayer. Is it a show or something in worship?
What was that?
There was something
Before 3 slides.
It's a show for 5 years.
Where is it? Oh, yeah, 5G trial. Yeah. 5G trial service in Korea, the first trial was in 2018. But as you know, in 2018, 5G was not yet standardized. So before they standardized it, the company by themselves, they made some trials. Even Ericsson, Nokia, Huawei, everybody making its own trials. But there is no global agreement on it, standard, and how it works and this. In 2018 December, they finished the standardization, and 2019 they are improving, and these days they are still improving. But now the standard is written, agreed on globally. Everybody now is trying to make things work as soon as possible and introduce to the market. Everything will work with everything, global. Whatever you produce in China will be sellable in Europe, in USA, in Middle East, wherever. Why companies go to the standards? Because they want to make sure that whatever they produce can be used not only in my country, but everywhere in the world. That's the beauty of the standard. Otherwise, every country will produce its own technology, and whenever you leave out of your country, you will be out of service. And the competition and this and that. That's why this is the good thing about the standard. So, any questions? So, how is everything so far? Any new information today? As usual.
This time we are sitting in wireless communication class.
Well, still, is it the same? Is it the same? Okay. Okay, this course is different. This course is that course was more scientific, equations and teaching you the concepts, and you were always complaining about these long equations, and I always tell you. But this is more kind of practical. Okay. And we will try to make something practical, not only theory. What is your name here?
My name is Trevor.
You registered now, okay. You sign your name as well. Where were you in the vacation, like 10 days? Where did you go?
In my country.
Really?
Yeah, I have worked.
You too?
No, I have Istanbul.
Oh, okay. You were in Istanbul. You went to your country too?
Yes.
You told me. Okay. So it was only 10 days. You didn't feel it, yeah?
Well, no, 1 month. No, 1 month.
1 month. Okay, 1 month because you left early.
Because I had work. I made a project, small project.
Yeah, I remember.
Very nice. Very good. That's great.
You are not doing that.
So anybody who didn't sign? Now, temporarily, the class timing is set as follows. We have today a lecture from officially on the system right now 3 hours, yes, from 3 to 6. Now we have the option to move 1 hour to another day. Do you like this, or you rather prefer to take it?
Maybe we can take it at 2. From 2 to 5.
2 to 5.
2 to 5.
Yes.
So 2 to 5, let's try next week 2 to 5. Today was an introduction, the first part of the course, introducing the syllabus and the content of the course. You missed out. Actually, I didn't know you were waiting there, sorry for that. I thought, because I told them to tell their friends. They didn't.
He didn't ask me.
They didn't. You called, but he was focusing too much.
Yeah, exactly. This is the problem.
Yeah.
So I have called counts.
Okay, no problem. It's fine.
Next time we
This is only the syllabus. And next time we'll start with here. Let's say 2 or 3, or shift 1 hour to another. What do you say about
I don't know my other classes. I didn't get actually the Excel file. I'll get from my friend and I'll.
Okay. The Excel, everybody, the institute share the Excel file of courses, the timing, the classes. So basically, if it suits you, we can shift it to another day 1 hour, or we can start it from 2 to 1. Okay. Are there any students, extra students in the future? If there is any students in the future? No. Good. Like guys, you can in this course maybe
There is a project also.
this project is going to make you multimillionaire. If it's not going to make you multimillionaire, I'm not gonna accept it as a project. The requirements are harder.
It's a good deal now.
Yes,
It's a good deal now.
good deal. Yes, who doesn't want to be rich? Yes.
Can you please share the syllabus for us?
Yeah, I will share the syllabus hopefully.
Can we make project in groups now or not?
Of course, I am your partner.